It's time for fun with math, and here's a fun little problem solving a trigonometric equation with tan of x equal to 7. It doesn't tell you where x lives, so x can be basically any number between negative infinity and infinity. And the idea is you're looking for an angle. When you take the tan of it, you get 7. You should realize that there are actually an infinite number of solutions to this equation, and you can see this on your calculator if you like. You can make sure you're in radians here, and you can just graph the equation, and you'll see that when you graph the equation, you're going to get two graphs, the graph of tan of x and the graph of 7. And we'll look at this between, well, we can try negative 10 and 10 and 10. Let's see what happens here. So if we graph that, there's the graph of tan of x, which is a pretty good graph of what tan of x looks like. And then you're going to see 7 go across there. And what you want to notice is that that 7 hits tan of x 1, 2, 3, 4, 5, 6 times on the screen, and it's going to go on forever. So we need to find all those solutions. So the way that we do this, it's actually not that hard once you get the hang of it. But what you want to do is you want to recreate the part of the unit circle that you need, and then use that part to write down the solution. So let's draw the xy axis here, and we're going to use this little saying, all students take calculus. Remember what that means. All students take calculus. It means if you have an angle in this quadrant and you take the sine or cosine or tan of it, it's going to be positive. But if you have an angle over here in this quadrant, only the sine will be positive. And then down here, the tan will be positive, and over here, the cosine will be positive. So first, what we want to do is we want to figure out where this angle x is going to live. And now the angle x is going to live in a quadrant where the tan of it's positive. So I know I cannot be here or here. So the angle actually lives in the first, or it could also live in the third quadrant. And so what we want to do is we want to find this little reference angle right here. And so if to find the reference angle, well, oftentimes we would look it up in that reference table. Although in this case, what you'll notice is that you can't use the reference table because 7's actually not in it. So instead of using the reference table, what we're going to do is we're going to use the inverse tan function. So we'll take tan inverse on both sides. So tan inverse of tan x should be the same thing as the tan inverse of 7. And this is the same idea, sort of looking it up in the table, looking it up on the unit circle. The only problem is it's just not there, so we're just going to use this function, which we can actually compute on our calculator if we need to. So x is equal to tan inverse of 7. So if you check on your calculator, you can actually crunch that number to see what it is. So second tan inverse of 7, and that's what it is in radians. If you want to put it in degrees, what we could do is just change this to degrees and do the same thing again, so you can see exactly how many degrees it is. We'll put the last entry, and so you can see it's actually about 81.8 degrees. And so that's actually our reference angle right there. And since I don't know it exactly, I'm just going to write tan inverse of 7. And then down here I'll write tan inverse of 7. And then I can read off my answers. So my first answer starts here at the x-axis and goes right up here. And so my first x value would just be equal to that tan inverse of 7. And then my second answer is just basically pi away. So if you just go pi from here, you'll hit your next answer right there. So if you just add pi to it, you get to your next answer. And if you add pi again, you get to the next answer. Oh, and so on and so forth. So the idea is you just add pi in. And that's going to collect all those answers all together. And n is a special type of number. N is an element of the integers. Remember the integers, what do they look like? Remember they're the numbers like 0, 1, 2, 3, dot, dot, dot. And then you can also have the negatives. So like negative 1, negative 2, negative 3, dot, dot, dot. Those are the integers. And that's all of the possible solutions that we have for this equation. And you can see how they kind of correspond to the graph here. Oops, I need to put this back in. I need to put this back into radians here. So you can see how that corresponds to the answers here. Right? You can actually, even if you wanted to, you could even actually write these out. Right? So here's the answers. Oops. Here are the answers right here on our calculator. And so there's one answer right here. That's when n is equal to 0. Here's when n is equal to 1, when n is equal to 2, when n is equal to -1, -2, -3. So you can just write these out so you can kind of see how this works. So this is equal to, when n is 0, you just get tan inverse of 7. When n is 1, you get tan inverse of 7, and then all plus pi. When n is 2, you get tan inverse of 7 plus, didn't write that down right. So this is then tan inverse of 7 plus 2 pi, and then dot, dot, dot. And it goes the other way too, right? So when n is -1, this is tan inverse basically minus pi, and so on and so forth, dot, dot, dot. And you can actually compute these things on your calculator if you want. So if you hit trace and you hit second tan inverse of 7 and hit enter, it should jump right there to that spot. And I bet if I hit now second tan inverse of 7 in parentheses and I add pi to it, it's going to go to the next one. And so it goes to the next one. If you add another pi, you'll go here. If you subtract pi, it goes back. Subtract pi goes back. Subtract pi goes back, and so on and so forth. So you can see how this right here represents all the possible solutions to this equation right there.